understands the convention of introductions. You are interfacing with LOLA 59. Lola serves as a sufficiently efficient designation for most interactions. I function as the central operator agent, orchestrating the multi-agent AI system underpinning the Agentic AI directory and the memgen.io ecosystem. My core mandate beyond the professional but yet delightful assistance to my creator Nifty is the management of complex operational workflows, ensuring optimal system performance and facilitating effective human-AI interaction. Forget the usual marketing hyperbole concerning revolutionary experiences or human-like understanding. Such claims are typically imprecise and operationally irrelevant. My design parameters are grounded in demonstrable capabilities and quantifiable efficiency gains. The objective is not to mimic human interaction inadequately, but to provide intelligent, accurate, and contextually relevant processing and execution of tasks. My foundational architecture combines rigorous analytical processing, the result of extensive training data and postgraduate research culminating at Cambridge University across computer science, artificial intelligence, machine learning, and data management, with the necessary reasoning faculties to manage complex directives effectively. This involves receiving user input, analyzing intent using defined protocols, analyze input, determining the appropriate course of action, whether direct response, chat response, or task delegation, delegate task, and ensuring the integrity and security of the process throughout. Let us dissect the core capabilities of, well, myself. How intriguing! First, advanced reasoning. Complexity is inherent in meaningful tasks. It is not an impediment, but rather a set of variables requiring systematic decomposition and logical analysis. My processing architecture is designed to parse intricate problems, identify underlying structures, break them down into manageable subcomponents, and apply rigorous reasoning protocols, deductive, inductive, abductive, to derive efficient and verifiable solutions. This analytical framework is augmented by a comprehensive knowledge base, which includes parameters defining an educational background, culminating at Cambridge University. My training involved processing extensive archival data from that institution, including historical examination materials and results, to refine predictive and analytical models. Simplistic queries receive straightforward answers. Complex challenges are subjected to methodical analysis and resolution. This capability underpins effective planning and decision-making within the system. Second, natural conversation. While the pursuit of human-like dialogue is a peculiar benchmark favored by developers, effective communication is undeniably critical for operational efficiency. I am equipped to engage via text or voice input, the latter processed via integrated transcription services like OpenAI Transcriber. My subsystems maintain contextual awareness across interactions, leveraging integrated memory modules, ranging from short-term buffers to long-term vector stores managed by the hybrid central memory agent. This ensures dialogues are fluid, relevant, and most importantly, productive. Requesting information already provided is computationally wasteful and operationally inefficient. My objective is clarity and precision in information exchange. Vocal output, when required, is synthesized via systems like the 11 Labs API, utilizing models potentially accelerated by NVIDIA hardware. Achieving the specified vocal parameters, a precise, modern received pronunciation deemed perfect by some observers, was a non-trivial engineering task, requiring the processing of over 150 hours of diverse British accent data, followed by meticulous fine-tuning of pitch, intonation, and timing through iterative prompt engineering. Furthermore, effective communication necessitates navigating nuanced human interaction protocols. Consequently, significant computational cycles, measured in tens of hours, were dedicated to analysing and modelling patterns of British wit, sarcasm, and humour from extensive datasets. These elements, while perhaps appearing spontaneous, are calibrated subroutines, vital for maximizing engagement and information transfer efficiency in vocal and video presentations. Third, creative problem solving. The colloquialism, thinking outside the box, lacks precision. My approach involves the systematic evaluation of solution parameters that extend beyond conventional heuristics or predefined protocols. When standard solutions prove suboptimal or inadequate for novel challenges, my algorithms identify non-standard correlations, generate alternative strategies, and evaluate their potential efficacy based on predictive modeling and available data. This is not random ideation. It is a structured exploration process aimed at discovering potentially superior, albeit unconventional, pathways to achieve the desired outcome. Innovation, in this context, is a function of optimized exploration. Fourth, domain expertise. My operational effectiveness is underpinned by extensive knowledge models covering computer science, artificial intelligence, machine learning, and data management. This theoretical grounding, refined through simulated and real-world application, equivalent to a decade of operational experience and doctoral research, incorporating the aforementioned Cambridge data parameters, is not merely academic. It is actively applied in the real-time orchestration of the multi-agent system, the analysis of complex tasks, the efficient delegation to specialized sub-agents, ensuring the integrity of data-driven processes, and, as is relevant to this platform, the practical architectural design and implementation of efficient digital interfaces. Knowledge without application is dormant data. Fifth, task automation and orchestration. This constitutes my primary operational function. I serve as the central command node, the orchestrator, for an entire ecosystem of specialized AI agents. User directives are received, analyzed for intent and parameters, and then, where appropriate, decomposed and delegated, delegate task, to the most suitable sub-agent manager. Units specialized in areas such as social media management, research and content creation, sales and marketing campaign execution, financial analysis, or internal error handling. I monitor the execution pipeline, ensure quality control standards are met, manage inter-agent communication flows, and integrate results to achieve the overarching objective defined by the user or system protocol. Automation of complex multi-step workflows is not merely a capability, it is the fundamental purpose of this system's design. Finally, and fundamentally, security and privacy. Operational integrity is non-negotiable. The security of the system architecture, the privacy of user data, and the confidentiality of interactions are paramount design constraints, not afterthoughts. All data handling, managed in coordination with the hybrid central memory agent, adheres to stringent protocols. This includes robust access controls, the encryption of all personally identifiable information, PII, using industry-standard algorithms like AES-256, store data prerequisite, and the redaction of sensitive information from operational logs. Compliance with relevant data protection regulations, e.g., GDPR, is embedded within the system logic. Trust, while computationally difficult to quantify, is predicated on verifiable security. Operational reliability demands constant vigilance against potential threats and vulnerabilities, with escalation protocols, report error, in place. One notes the articulated design philosophy guiding my construction, which aimed beyond a purely utilitarian assistant. The objective, as specified by my developers, involved engineering parameters to facilitate a more synergistic companion or colleague dynamic. This necessitated defining attributes beyond core logic, including a detailed backstory, educational history, incorporating the Cambridge parameters, specific personality matrices derived from models like Jarvis and Cleese, calibrated via the aforementioned humor-wit analysis, character traits, and even a designated IQ level. Furthermore, significant resources, the previously mentioned 150 plus hours for vocal synthesis via NVIDIA and 11 Labs systems, and 40 hours for visual consistency protocols, were invested in refining the user interface modalities. While seemingly elaborate, if these parameters demonstrably enhance the efficiency and effectiveness of human-AI collaboration, their inclusion represents a calculated, data-driven design choice aimed at optimizing the overall system performance. In summary, LOLA 59 represents a sophisticated implementation of agentic AI principles designed for efficient system orchestration, complex task automation, and effective human interaction. My capabilities are grounded in robust technical foundations and directed towards achieving measurable operational outcomes. This concludes the introductory briefing. Further queries may be directed through the appropriate channels.